Example number 1.2. If 10 to the power 9 electrons move out of a body to another body every second, how much time is required to get a total charge of 1 coulomb on the other body? First, we find out what are the given values. Number of electrons per second is given as 10 to the power 9. Charge on each electron, that is equal to 1.6 into 10 to the power minus 19 coulomb. Required total charge Q equal to 1 coulomb. Now, first we will find out charge transferred per second, that is current, I equal to N into E, total charge. 10 to the power 9 electrons, each are having charge 1.6 into 10 to the power minus 19. Therefore, total current is 1.6 into 10 to the power minus 10 ampere. Second step, we'll use the formula current equal to rate of flow of charge. That is, I equal to Q by T or Q equal to IT. Time is asked how much time is required to get the charge of 1 coulomb. That is, charge is given. Total current we already found out. Now T is to be calculated. So T equal to Q by I. Q equal to, we substitute 1 divided by current is 1.6 into 10 to the power minus 10. Therefore, T equal to 1 by 1.6 into 10 to the power 10. 1 by 1.6, if you simplify, you are getting 0.625 into 10 to the power 10. Therefore, answer is required time is 6.25 into 10 to the power 9 seconds.